Section 8.3 is actually going to get in this idea of similarity, which this is what the really chapter is about. So what Section 8.1 and 8.2 are kind of really doing is getting you set up to some big concepts involving similarity, all right?
Yes.
So let's define what similar means, and we're going to talk about similar polygons. We're going to eventually get to similar triangles. Imagine that, triangles again. But the whole idea about similarity, it says two polygons that are similar basically have corresponding angles that are congruent. Okay, so that's big key, and we've heard of that with congruent polygons before.
Right. But
notice it says the lengths of the corresponding sides are proportional. Now, what does that mean? Proportional.
Yeah, so like, okay, I'm thinking about a proportion. So like if from one side length to its corresponding side length is maybe 1/2, all of those corresponding side lengths would have that same ratio.
Okay, and
I'm going to have equivalent fractions.
I'm going to write down what you just said, the same ratio, because really a proportion is two ratios that are set equal to each other.
Right.
Okay, now with polygons though, polygon could have 5 sides, so every corresponding side that you're matching up should have the same ratio. They should all end up being, like in your example, was 1:2. It could be 5:4.
Sure.
Right? They should all have the same ratio.
That doesn't mean they're all just 1 and 2. The ratio. So that's the simplified ratio.
So similar polygons, the two things that have to hold true is the corresponding angles have to be congruent and their corresponding sides are proportional, or they have the same ratio.
Okay.
Right? Again, that word corresponding, okay, you're going to hear us kind of stress that on some of these examples. Now, because we're going to be using this quite a bit, we have a symbol for it, and it's this guy right there. So what we call a tilde, actually. We've seen that symbol involved in the congruent symbol. It's like you take the equal sign away from it.
Because these are not equal.
No.
They are similar.
Exactly.
All right. So we've got 2 figures up here. And I'll tell you right now that they are similar figures. And they're not any like fancy kind of polygons that we've spent a lot of time focusing on. They're just 2 polygons. And I've written up here a similarity statement. And I want you guys to realize that the similarity statement is just like writing a congruent statement where those corresponding parts have to be in the same location. It's just that now they're not congruent parts necessarily. The angles will be congruent, but the sides will be proportional.
Okay.
Okay, so when I see like that I'm starting with A, then B, so then this segment AB must correspond with segment QZ.
That makes sense. That order tells you that. Okay.
All right, so just like what we did with congruent statements,
all right,
the similarity statements are going to be like that. The first thing we're going to do is we're going to write a proportionality statement. And when we do that, what I want you guys to realize is we're going to keep track of what pieces are proportional. All right, that makes sense, right? Proportionality statement. So we just said segment AB corresponds to segment QZ. So that's going to be the very first thing we're going to write, that segment AB and QZ make a ratio that should be the same ratio
as all the other corresponding
parts.
Okay.
So this ratio right here should equal what other ratio? Give me another set of sides.
BC.
So BC
to ZW.
ZW.
And I could call that CB and WZ. We're not talking about like with the last chapter, we had to make sure certain points matched up with reflections.
Because we're not mapping these.
No. So and notice here, so far we do have a proportion, but then we're trying to make a proportionality statement. Are we going to have lots more ratios?
We're going to have a lot of ratios. We're going to write all the ratios that exist of all those corresponding parts.
Okay. All right. So I see, let's do CD to WP, and I'm looking at that from the similarity statement again. Match up the corresponding pieces, because the figures may not be actually drawn exactly in the right order.
Exactly.
And this one we did.
I also want you to realize that every time you're starting with this larger figure, okay? Because we do in our proportionality statement, we do need to keep those pieces that correspond with each other in the same part of those ratios. So when I say, okay, this is the larger to the smaller figure, or the one that starts with the ABC, the very first figure to the second figure.
Okay.
Okay, we need to always keep them in that same ratio.
And I a lot of times go left to right just because it's just order. You know, you could have started with, you could do the reciprocal of all of those, which
And it
we
would
know
be
would
the
work.
exact same.
All right, let's finish it off. So DE to PY, then EF to YT, and then AF to QT.
That right there is what we call a proportionality statement, where it lists every piece that's proportional.
And notice there are 6 different ratios because there are 6 sides in each of those polygons.
Right. So if I had just given you 2 triangles and said list the proportionality statement, how many
you would have
pieces would I have?
3 ratios.
3 ratios.
Now, just to kind of add on to this, the proportionality statement is only just to communicate basically what things are corresponding, matches up. You could take 2 of those ratios and set up a proportion that you could actually solve.
Absolutely.
Right? You're not going to use all 6 ratios and solve a proportion that way. Never.
No.
You're going to use just 2 of those ratios at a time to solve, just find missing pieces.
Exactly. All right, now when we list congruent angle pairs, because the sides are proportional, but the angles are congruent.
Okay.
Okay, again, looking at the order here does matter.
Okay.
So what angles do you see from this that should be congruent?
So angle A will be congruent to angle Q. Angle B will be congruent to angle Z. And hopefully you guys get the idea. Angle C is congruent to angle W. Angle D is congruent to angle P. Angle E is congruent to angle Y. And then the last is angle F is congruent to angle T. And again, I'm looking at the similarity statement when I'm doing this. And it's the order that's communicating into it. You don't necessarily want to look at the picture because the picture doesn't always have it in the right order.
Well, and I could have drawn one figure that's facing this way and one that's maybe a reflection of it too.
Exactly.
It's, scaled down and a reflection. So, yeah, I like that looking at the similarity statement.
All right, so what we're going to do is we're going to apply this idea, what we know about similar polygons, and actually decide if we have some.
Okay.
All right, so keep in mind, if polygons are similar, all right, keep this in mind. You have to have corresponding sides that are proportional, corresponding angles that are congruent. So the first thing they say, are these similar? And they say, if so, give the similarity statement. If not, explain. So
the similarity statement, that's like when we wrote a congruent statement, we said 2 figures were congruent. This is saying 2 figures are similar.
So like this right here was a similarity statement. We gave that to you. These are different. A lot of times people think these are the same, right? Proportionality statement and similarity statement are different, right? I wouldn't say they think they're the same. They get mixed up with it. I've seen that in the past.
Right.
All right, so here's the deal. I'm looking at the 2 triangles, and they don't necessarily look like they're drawn exactly the same way. So when we are matching up corresponding pieces, we do have to be careful, all right? If we're looking at the side lengths,
okay,
all right, if we're looking at the side lengths, what would be a good way to kind of know what matches up? Notice they give you all 3 side lengths.
Yeah. Well, and like, for example, I noticed some kids will always say, oh, there's one set of angles that they have marked as congruent. That doesn't mean that the other sets are congruent. And it's hard to tell what would correspond with what. So just looking at the sides, well, if they are similar, shouldn't the longest side of one match up with the longest side of the other one?
Exactly. So what is the longest side in this one on the left?
Yeah, the one on the left is 18, which would be side MN.
So side MN is going to correspond, I'm just going to make a note, to the longest side in the other one, which
would
is
be the PR.
All right. So if I was setting up a ratio, it would just be 18 to 12.
Right.
All right. So if I simplify that down, that would be what?
9 over 6, which would be a 3 over
2. Okay. So I like that you did that. Pick the largest side with the largest side. Let's pick, what do you want? Do smallest?
Let's do the smallest. Smallest.
Okay. Good. So the smallest side over here is
the LM.
LM.
And that would correspond with the PQ,
which is 10.5 to 4. All right. And when you simplify that down, let's see.
Well, it's not going to be as pretty.
No.
Because we've got a fraction.
If I multiply this by, this would be 105 to 40.
Yeah, and then that's easier to simplify. Yeah. So let's see here.
5 goes into both of them, I know.
Yep.
So that would be 8. What goes into?
I think when we simplify, I think 21 over 8 would be the simplest form.
Now, here's the deal. Those are obviously not the same.
Okay. So then I know that these are not similar.
Yeah.
Because all the sides have to be proportional.
Exactly. Since those are not equal ratios, then the answer to this would be nope. And why not? Well, because corresponding sides are not proportional. Now, don't just say the sides aren't proportional. Make sure you're clear on that. What do you mean, which sides?
So it has to be corresponding sides.
Make sure you're clear on that. The corresponding sides aren't proportional. If they said corresponding sides don't have the same ratio,
that would be okay
that would
too.
be acceptable as well. Okay. Yeah. Now, I do want to comment on what Ms. Hooker we said before also at the angles. We know by definition the corresponding angles have to be congruent, and they didn't label that, so we don't know that. So we would have to know that here. Now, tomorrow is a little bit different story with
we'll
the
look
triangles.
at some more
okay.
details with it.
All right, let's try the same question, just the different polygons.
Right. Now we've got quadrilaterals. So we've got some four-sided figures. And again, are these polygons similar? Now I want you to look at the pictures here. What do you notice?
Well, first thing, because going back off of the other one, I noticed that angles are labeled.
Yes.
And I see, to me, corresponding angles are all labeled congruent.
They're all marked
So
congruent.
that's a good start. That doesn't guarantee that these are similar polygons, but we know already corresponding angles are congruent. So now I would be looking at the sides.
Okay. And knowing those corresponding angles helps us to really look at the corresponding sides. I don't have to do as much guessing work.
So they are congruent. Now we could do kind of what we did on the last one and pick like the matching small, kind of in the correct idea. You could also use the angles to kind of know which ones match up too. So.
Absolutely. So what corresponding sides do you see here?
Well, I'm going to start with the 15.
Okay.
On that,
So
the one on the
15
left.
is our XW. And what is that going to correspond with?
The QP. And
So
a
you said
couple
that's a
reasons.
15 over
10. So that would be 3-2. Now, a couple of reasons why those correspond is because they're the two largest sides, or the largest side in both of them, and 15 is between a 2 tick mark and a 1 tick mark. 10 is also the same day.
Exactly. Okay, pick another set of sides.
Let's do the XY and the QR, and that is 6-4, which is also 3-2. Now, those are the same, so does that mean we can go ahead and say they're similar?
Well, if we think about it, the definition says that all corresponding sides would have to be
so we only have 2.
We have 2. We got to keep going.
All right. YZ to RS, so it's 9-6, which is also 3-2. So we're in the right direction.
It's looking good. Okay. And then the last one.
W or ZW and SP, so that would be 12-8, which is also 3-2.
All right. So the question says, are they similar?
Yes.
So these are similar. Then it says, if so, give the similarity statement.
Okay, so that would be naming the two polygons in the correct order because we want the corresponding pieces to match up.
Exactly.
Now, since these aren't triangles, we don't really need a symbol. We're just going to name it with all 4 vertices.
Okay.
So let's name the first one X, Y, Z, W. And I want to make sure they go in order. I'm going to use a similarity statement, and I'm going to go Q, R, S, P. And we kind of helped you out on this. These were drawn exactly matching up. But you can look at the angles. Okay, so X had 2 tick marks. Q has 2 tick marks. Y has the right angle. R has the right angle. So on and so forth.
Perfect. Okay, so it says, if so, we're going to give the similarity statement. If not, we had to explain. Do we even need to explain then here?
Nope.
No, because it did. They were similar, and here's our similarity statement. Awesome.
So here's another example. It says you have a 4-inch by 6-inch photo. That's a pretty common size of a photograph that you want to reduce to fit in a frame. That's pretty typical. I've had to do this where you kind of had to scale down. You don't want to distort the picture, so you want to make sure they're similar in a sense.
Right.
Okay. So you have a 4 by 6, and I'll make a note of this. So it's always nice to have a little picture. So 4 inches by 6 inches. And you want to reduce it to fit a frame. And the frame is 1.5 inches wide. Now, if I draw this picture, all right, the key here is understanding what does that kind of correspond with the other one. Since this is the width, in a 4-inch by 6-inch, how do you know which one's the width?
The width will be the shorter one. The length will be the longer one. So when I'm talking about in this one, the width, it's going to correspond with the 4. Now, when I draw my picture, I'm going to make them look exactly the same. I'm not going to try to trick myself.
Yeah, I'm going to put, what she's saying is I'm going to make sure the width, kind of I had a vertical width here, this is the vertical width here. All right. The question says, how long will the reduced photo be? So really the question mark is this. How long is the reduced photo?
Okay.
All right.
Well, we know that those sides should be proportional if these are similar, which we want them to be similar here.
All right.
So I'm going to say that the 4 is what's corresponding with the 1.5.
So one width to the next width.
And the 6 is what's going to be corresponding to my unknown piece.
And what do you want to name this unknown piece?
Let's call it X for right now.
Okay, which is a lot of times what people like to do.
Yeah.
Now, I want to stress again the whole idea of the width and the length. I could have said you have a 6-inch by 4-inch photo. That doesn't mean the 6-inch is the width. Make sure the smaller number is the width. Stressing that, okay? All right, so we can just cross multiply, right?
Yes.
So it's going to be 4x equals 9. So x equals the 2.25
or if you said 2 1/4
inches,
same thing.
okay,
Inches.
or 2 1/4, which really, if you think about it in inches, that's more common. And this is the length of it, so how long it is. Now, would that be a reasonable answer?
Sure, yeah. It's a little longer than the width.
Uh-huh.
It's definitely shorter than the original length.
Which it should be because you're reducing the photo.
Right. Good. Okay, scale factor. This is the next thing that we're going to be talking about. Scale factor is the ratio, so it is a ratio or a fraction, a lot of times you'll see it, of the lengths of 2 corresponding sides of similar polygons. All right, so when we write that ratio, like in our big proportionality statement, okay, when we wrote all those ratios that compared all those corresponding side lengths, if you just take one of those ratios, that will give you the scale factor.
So like that one problem that we had, the 2 quadrilaterals, can you go back real quick?
Okay, yeah.
Find where that is. That one. So the scale factor essentially would be the 3:2.
And notice the scale factor is the same for all of those values because each one of those are congruent, are equal when we make our proportionality statement. We're saying each one of those sets of corresponding sides have the same ratio.
Okay.
So that ratio is our scale factor. Now, do we need to find all of them? No.
No, because if they say, like this next question says, what's the scale factor? That already is telling you those figures are similar, right?
Right.
Okay. So if it says, what's the scale factor of triangle KMW to triangle SCJ? Does it matter how you write it? Because like the last one was 3:2. I know the reciprocal of that would be 2:3.
Right.
What do you think?
When they say scale factor, it should always be in the order that they give them to you.
Okay.
So I want to start with a piece from the KMW.
Okay.
And then I want to, on the bottom, have a piece from the SCJ.
Okay, that sounds like a good idea. All right, so I see 3 sides in each of them, and one of them has a decimal. I'm not even going to look at that one because that takes longer to simplify.
I wouldn't blame you.
So I'm going to pick, and based on the order and the name, and also kind of even looking at the lengths, I want to pick like a larger with a larger one. So like, for example, KW corresponds to SJ. So that would be 15 to 9. And I'm doing that order because that's what they're saying.
Exactly.
And then that would simplify down to 5 to 2.
5 to
5 to 3.
Okay,
Sorry.
I was like, wait a minute.
5 to 3. Sorry.
Yes, 5 to 3. So 5/3 is our scale factor.
Perfect.
That means that for every 5 units in our first figure, we only have 3 units of that same whatever scale into the second figure.
And I like that you said you didn't have to do it for all of the sides because since you already know they're similar, you just need to pick one pair.
Yeah.
All right. Let's apply this idea, and we're going to actually calculate the scale factor from this picture here. It says of the wall to the painting. I know this lovely artwork here.
We put the artwork on a white wall. Yeah, it is beautiful, Mrs. Palermo. I think those are the most beautiful mountains and sun and ocean and cloud I've ever
exactly. Seen. It's great. It has a little snow on top of the mountains. All right, so the fact that it says wall to painting is important. All right, and so the painting is obviously this picture, and then the wall is
the white space.
The white space. Okay, so we want to first find the scale factor. So let's do that.
Okay.
And the scale factor basically is saying these are similar. So, and we're doing wall to painting. So what would I compare
We
here?
lost a number there, by the way.
Did we lose
Yeah,
a
we
number?
lost the 15 up top. Sorry about that. Okay. We can pick either the length to the length or the width to the width when we're making our scale factor. It won't matter. And now that we've got a 15 there, it sure helps. We could have done it with the two widths. But let's do our length to length. And since they say wall to painting, I want to do the wall first. So the 15 over 6, which can simplify to give us a 5 over 2.
I was just predicting that from the last
That's
slide.
right. That's exactly right.
So the scale factor would be 5 over 2. Now, you could write it like this, of course. We just often write it as a fraction because we can do more with it.
Right.
All right, so that's the first thing. It says, then find the ratio of their perimeters, which is the wall to painting again. Now, here's the deal. To find the ratio of their perimeters basically means we need to find their perimeters, right?
Right.
Okay, so we're just finding perimeters of rectangles.
So we're just adding all the sides. We can do that.
So let's do the perimeter of the wall first.
Okay, so we could do our, we could do our 15 plus 8 and take it times 2 because there's double of those. We're going to have a perimeter of 46.
It's just super quick. So 46 is the wall.
And the perimeter of the painting, I could take my 6 plus my 3.2 and take that times 2 because I've got 2 lengths, 2 widths, and that's going to give me 18.4.
All right, so if they said go ahead and find the ratio, so that would be take 46 to 18.4. And when you simplify that down,
it gives us 5 over 2 also.
So this is the ratio of the perimeters.
Well, that's weird. The ratios are the same.
Why do you think that's the case?
Well, I'm thinking about it, and I know that when I talk about just 15 over 6 simplifying, well, it kind of makes sense that when that's just one of the sides, if I added all the sides of one and all the sides of the other, it should still simplify.
And because these two figures are already similar, that's going to happen. Doesn't matter how much, how much more you could keep adding as long as you're adding the same amount.
So that should happen every time.
Yeah, and imagine this: we have a theorem.
Who knew? We haven't done a normal theorem for a while.
Well, we're going to see them more in this chapter.
Yes.
So theorem 8.1 says if two polygons are similar, so you know that they're similar, then the ratio of their perimeters is equal to the ratio of their corresponding sides. All right? So in kind of here, we start this. This basically all mean the same thing. So the perimeter ratio, the side ratio, and the scale factor are all the same thing. Okay, and again, this idea of the corresponding sides, we just wrote side ratio to kind of be short and sweet. Now, this is helpful because, like on this last one, would you had to actually calculate the perimeters if you knew this theorem?
No, because once I knew the scale factor was 5 over 2, that meant that the perimeter ratio would have to be 5 over 2 also.
And guys, I want to really stress that this theorem is very helpful. Some students will forget to use it. It's going to become in handy. It allows you to do less work, and sometimes you won't be able to do the problem without knowing it.
Yeah, you may not be able to find the perimeter.
So why don't you do one with us here?
Okay. So they tell us we have two triangles that are similar, and they've given us 2 sides. Now, are these corresponding sides?
Let's look. I'm looking at the similarity statement. AC and XC, they are.
So these are huge. Corresponding sides of similar triangles.
Okay.
Now they tell us the perimeter of triangle ABC is 84. Okay. The question is, what is the perimeter of triangle XYZ? Now, this is one of those problems that I could not physically do this without the last theorem.
Okay.
Because we only know one set of sides and we don't know that they're equilateral. We don't know anything about these triangles other than the fact that they're similar. But when I have 2 side lengths, 2 corresponding side lengths within similar figures, what can I find?
I could find the scale factor.
I can, because I can write a ratio of those corresponding sides. Okay, so which segment do you want to start with?
Let's just do the 21. So AC, 21 over the XZ, so 21 over 49.
Okay.
And that simplifies to 3/7.
All right, so that right there is my scale factor.
Okay.
Now, they didn't specify which one I had to start with.
Yeah.
I noticed they seem to start with ABC, triangle ABC every time, so I just did that so I know I'll be looking for it.
Yeah, stay in the order they give you,
I also wrote it off to the side just so I remember which one, because they don't ask for the scale factor by itself, so that's not really my answer, but that's going to help me to be able to find the ratio of the perimeters, because what do you know about the ratio of the perimeters?
The ratio of the perimeters is the same as the scale factor. So I could say 3/7 is equal to, well, if one of the perimeters is 84, and that goes with triangle ABC, so that should go on top. And we don't know the perimeter of the other one, I'm just going to say P for capital P for perimeter.
Sounds good.
So again, when you compare one perimeter to the other, that is the same thing as the scale factor or the
Exactly.
ratio of corresponding sides. So you go ahead and solve it. 84 times 7 is 588. You divide by 3, it's 196. Which I think about this, that perimeter of that triangle, XYZ, should be bigger than triangle ABC because XZ is bigger than AC.
Right.
So you should end up with a bigger perimeter around.
Exactly.
Now, just a little side note, you don't actually have to, she mentioned this, you don't actually have to find the scale factor. You could have just said 21 over 49 equals 84 to P and then cross multiply. What's nice about finding the scale factor is it's a simplified answer.
Right.
Simplified numbers are a little easier to work with.
Right.
So just a suggestion to think about. All right, we have one question to go. And this time, I'm giving you a similarity statement, which basically means these triangles are
Similar.
So that's going to communicate what corresponding angles are congruent, what corresponding sides are proportional.
Right.
It says find the value of A. So this is what we're trying to find.
All right. I'm going to look at that and say, well, I've got several things already marked, and I'm going to go back to my similarity statement and just see where they are. So like looking at YW.
Okay, so YW is right here.
Yeah.
And in this picture, YW, or in the similarity statement, YW.
Okay. That must correspond with the UW.
These two correspond. So
No, UW.
UW, sorry. I did it in that
yeah.
one, and then I highlighted wrong over there.
That's funny.
So UW.
There you go. So I'm going to write that ratio right now. So let's write 12 over A. And I could have done it in the other order and said A
Now,
over 12.
notice she's starting with this triangle, the 12, and going to this triangle A. So we got to be consistent on the other ratio.
Now I'm just going to make sure that they match up. W should correspond with the WV, which they do. Okay, so I'm going to do my 6.4 over 5.
Now, you could remember from the last couple days, you could write this proportion,
Do
do
the
the
reciprocals, lots of
switch
other
the
ways.
means or switch the extremes, whatever.
Yeah.
Okay, so we go across multiply.
So we're going to get a 6.4A. And when I take 12 times 5, that's going to give us a 60. And then when I take 60 divided by 6.4, that's going to give us a 9.375.
Okay.
And that's all I had to do was find the value.
All right, so if you think about it again, so the reason why we knew which matches was looking at the similarity statement. So YW corresponds to UW, so that's why we did 12 to A, and then the XW, all right, XW is right here, to VW. That's why it was doing that. All right, and think about, does this make a logical sense? All right, if this was 9.375.
Well, yeah, because I know it's less than the piece that it's corresponding with, the 12, which the 5 was less than the 6.4. And I also noticed that the 6.4 was smaller than the 12, so the 5 should be smaller than our 9 point. So within those triangles,